Okay, so yesterday or the day before, we were talking a little bit about acids and bases. We spoke about some simple definitions like the Arrhenius and the Bronsted-Lowry. We said that acids are proton donors and bases are proton acceptors if they're Bronsted-Lowry. And it's very important that you work through your classwork 1 through 10 so you have a solid understanding of identifying acids, bases, and their conjugates, and also predicting products of acid-base reactions in which both substances are Bronsted-Lowry. So make sure you're comfortable with that. What we're going to talk about briefly today is pH. And you probably learned a little bit about pH in middle school. And you might have even run some very simple labs where you used pH paper. We talked a little bit about some of the foods you eat being acidic or basic. And now we'll talk about that more in regard to their pH and where they fall on the pH scale. Now what you may not have known is that pH stands for power of the proton. It's an acidity scale, and you can easily calculate the pH of a substance if you know the concentration of protons. So one of the first formulas we're going to use is highlighted in yellow. It says pH is equal to negative log of the proton concentration. Now again, think back to middle school, maybe a little bit of your freshman bio. What do you recall about pH?
Less than
Something can be neutral with a pH of 7. If it's,
Less than 7.
one at a time, go ahead.
if it's more than 7, it's basic.
If the pH is more than 7, it's basic. You may have heard the term alkaline. Alkaline and basic are synonymous. And if the pH is less than 7, it's acidic. Okay, so we're going to calculate pHs of solutions and determine if the solution is acidic, neutral, or basic. And we also can make comparisons as to whether a solution is more or less acidic than another solution. So as you had said, the pH of a neutral solution is 7, and if the pH is less than 7, typically between 1 and 6.99, if you will, although some pHs can be less than 1. So a pH less than 7 is acidic, a pH greater than 7 is basic. Can it be greater than 14? Not typically. Although I wouldn't be shocked if you saw something measured as such. But typically we say it goes to 14. That deals with the kW of water, though. That's a little more than we need to know. What you also see in this pH scale is 7 is a pH of neutral. And as the pH decreases, the solution gets more and more acidic. So a solution with a pH of 2 would be more acidic than a solution with a pH of 5. Similarly, as the pH increases, the solution gets more basic. So a solution with a pH of 13 is more basic than a solution with a pH of 9. So as the pH decreases, the solution becomes more acidic. As the pH increases, the solution becomes more basic. What you're also going to find is as the concentration of proton gets greater and greater, the pH gets less and less. And we'll see that in a few calculations in a few minutes. Some pHs of common substances are listed here. 0.1 molar hydrochloric acid. Hydrochloric acid is the acid found in your stomach. It facilitates digestion. When somebody has an upset stomach, very often the acid is kicking back up. You see this a lot. It's very common today. When I was growing up, we never heard of acid reflux. And now it seems like a lot of adults, kids, and babies have acid reflux, where the acid in your stomach is kicking back up into your esophagus, and that causes a burning. And I know, like with my dad, he has that. He takes stuff, but I think his diet also affects that. So sometimes it's not just how you're put together, it's what you eat. Heartburn, yeah, it feels, it's not really your heart, but it's like kicking up through the esophagus. And this is one of the things, one of the many things that's very concerning with some of the eating disorders, especially bulimia, where people will vomit excessively. Now keep in mind you have acid in your stomach, and when you vomit, it's reverse peristalsis. So instead of going down, it's coming up, and some of that acid kicks back up into the esophagus and into the mouth. So with excessive vomiting, you have a lot of this acid in your mouth, and this acid will eat away at your tooth enamel. So that's a major concern, and the dentist will spot that right away and tell a parent and say, listen, there's a lot of tooth decay, if you will, and it's not just from eating junk food and not brushing your teeth well, but they'll see the back of the enamel on the teeth has really eroded badly, and once you erode enamel, it really doesn't come back very well, if at all. So it's a major concern, and that's because the acid comes back up. So your stomach content's also very acidic, around a pH of 2. Vinegar, 5% of vinegar is acetic acid, so vinegar is acidic. Vinegar works great to put down your disposal. If there's a stinky kind of odor, the vinegar will help neutralize anything that's building up in there and hopefully get rid of the stench. Soda, very acidic. My husband always thought that Diet Coke for breakfast was delicious, and it's really not good for your teeth or your system. Now, it's okay to drink soda with a meal because in your meal you have other foods in there that will neutralize the acidity of the soda, but just drinking soda for breakfast, that's really not good for you. I don't recommend it. Soda's really not that good for you anyway. There are better things to drink. Grapes, apples, beer, acidity around 4. Bread, about 5.5. Urine is slightly acidic, but not too bad. Saliva, a pH of 7. So that's what you would expect. Interestingly, with urine, it's not a cute story, but there have been some instances that you've probably seen on the news where there's an earthquake, there's some type of environmental disaster, and people get trapped and they have nothing to eat or drink, and they survive by drinking their own urine. And urine is relatively neutral, so it's not going to affect your system in a negative way. And that is a way that some people actually have survived. And I remember back in 1989 sitting down to watch the World Series, and they were in California. It was a Bay Series. It was San Francisco versus Oakland. They were, it was definitely San Francisco versus Oakland. That was like with the Bash brothers. It was McGuire and Canseco. And in any event, there were a lot of people. I told this story yesterday, right? There were a lot of people in the stadium that day. It was about 5 o'clock during rush hour when this I was sitting down watching the game. I was in college, and all of a sudden the TV went dark, and then it came back on, and then it went out. I'm like, oh, what's going on? I want to watch the game. And what had happened was there was a major earthquake in San Francisco, and the Bay Bridge, if you will, just fell. It was a 2-deck bridge, and I remember Al Michaels, he was calling the game. He's like, I think that's a 2-story bridge or a 2-level bridge. And he goes, but it's only 1 now because 1 level fell into the other. And about 4 days later, they're looking for survivors, and they pretty much had given up hope. But this one man had survived. He was stuck in his car, and he drank his own urine. He had a bottle of water. He finished that, and then he used the bottle. And so the moral of the story is urine has a neutral pH.
Wait, if you like drink a lot of water, you know how like when you're really hydrated and you pee, it's like clear. So like if you drink that, isn't that just like water, like pure water? Or like what's in it?
No. If you actually analyzed urine, if you were to do an analysis of urine, there are a lot of substances in urine, so it is not water by any means. And Tommy, honey, that sounds like a great project for you over the weekend. Why don't you look up what's in urine? I think you'll find catecholamines. Let us know when I see you next Tuesday. All right. These substances are more basic. Blood has a pH of about 7.4. blood pH has to maintain at 7.4. There's a big buffering system in the body that facilitates this process. If blood pH drops too low, acidosis can set in. A lot of processes don't run in an acidic environment, so if blood pH gets too low, that can affect a lot of bodily processes. Ammonia, which you clean with, has a pH of about 11, and sodium hydroxide, which is lye, has a pH of about 13 to 14, depending on the concentration. And as we said, vinegar, for example, would be more acidic than bread, and ammonia is more basic than blood. So we want to know how to calculate pH, pOH, proton concentration, and hydroxide concentration. We'll talk about pH and pOH today, and we'll hold the other. And that's really as far as the quiz goes. So I'll mark the point where the quiz goes so you're comfortable with it next week.
This might be a weird question, but when you get like a UTI, does your pee get more acidic? And like,
A UTI is a urinary tract infection. A urinary tract infection is a bacterial infection.
yeah, but like.
And based on the fact that you have some burning, you might guess that you do have some acid buildup. I'm honestly not sure, although it makes sense, and I don't think it gets more basic. And I do know that a urinary tract infection left untreated could cause kidney problems, and in a woman who is pregnant, it could cause premature labor. And I'm guessing it is more acidic in nature, but that's something we're going to look up in a few minutes. That's a really good question. But it's a bacterial infection, which is why it needs an antibiotic. And then the other thing to be careful with is some people are allergic to sulfa-based drugs, and that's commonly what you use to treat it. So that's something else to watch out for. Don't throw the calculator on the floor. Okay, let's talk about how to calculate pH. You need a calculator out. I know some of you have different calculators. I'll try and pull a whole bunch out so that we do every which way. All right, pH is equal to negative log of the proton concentration. Yes, logs. Logs. Guys, logs on your calculators. Shh. If you have the TI-30X, Roman numeral 2S, you'll see log right under the second button. If you have this little guy, shh, you'll see log right here. I don't know where it is on the multi-view.
It's right under the second one.
All right.
Where? Right under the second one.
The multi-view, shh. The multi-view will work like this one. Oh, Tommy, I'm so proud of you. This one's very different. Does anybody have this little guy? Okay, so we'll do them both. All right, guys, we're a little off topic and we're on candid camera. Okay, the first example, we're going to focus on this formula first. pH is equal to negative log of the proton concentration. The first example says that the proton concentration of a solution is 1.00 times 10 to the negative 4 molar. We want to calculate the pH of the solution, and we want to know if it's acidic or basic, and then you'll explain. So this one is very straightforward. They give you the concentration of proton. We know pH is equal to negative log of the proton concentration. We do negative log of 1.00 times 10 to the negative 4. And there's two things I want to point out here.
Why is there so many zeros after the 4?
So Chloe's question was the first thing I was going to point out. Why are there so many zeros after the 4? This quantity here, the concentration of proton with a unit of molar, has 1, 2, 3 sig figs. When you record pH or POH, the sig figs come after the decimal point. So pH here is 4.000. 3 numbers after the decimal signifies the 3 sig figs that you were given. So pH and POH are a little bit different in sig figs. They count after the decimal point, and they're all significant after the decimal point. The other thing I want you to make sure you can do is in your calculator, you want to be able to calculate this with simplicity. You've got negative log 1 EE negative 4 equals. Now, McKaylee, on here, you're going to put the concentration in first, 1 EE negative 4. You're going to hit the log button and then the plus minus button. It's a little bit backward. It's not hard to use, but if you don't like it, let me know. You can use mine. The other thing I want to point out here is the following. And for those of you moving to College Chem, taking an SAT 2 chemistry test next year where you don't have the calculator, you have to be comfortable with this. It's very easy.
But you have to do it by hand?
We'll hit that in a bit. Say it again.
Wait, you don't have a calculator, so you have to do it by hand?
But it's easy. Take a deep breath. It's good.
Wait, do you have a calculator?
AP Chemistry, no calculator on part 1. Okay. If you ever have 1.00, 1.0, whatever, times 10 to the negative 4th, the pH is going to be the absolute value of the exponent. If you have a number greater than 1 here, the pH is 1 less than the absolute value with a few numbers after it. I'll point that out in a minute. With a pH of 4, the solution would be acidic because if you have a pH less than 7, the solution's acidic. If the pH were 2, would that solution be more or less acidic? More, because the lower the pH, the more acidic, the farther from neutrality. Okay? The next point we want to make, it says for strong acids. We talked about 8 strong acids the other day. Now for the quiz, I'll tell you it's strong. For the test, you have to know your strong acids. The strong acids, hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, nitric, chloric, perchloric, periodic. It's in your notes already. Don't panic.
For the quiz or for the test?
For the test. Okay?
Wait, when is the quiz?
The quiz is looking like the 16th. All right.
In 2 weeks.
If you have a strong acid, and we talked about this in the laboratory that we did the other day. If you have a strong acid, you also saw it in the little video. A strong acid is characterized as such because it ionizes completely. You know acids generate protons. Strong acids ionize completely. If you have a monoprotic acid, 1 ionizable proton, the concentration of the acid and the proton is equal. That's the case for strong acids. Strong acids ionize completely. The concentration of the acid is equal to the concentration of proton. With weak acids, that's not the case because they don't ionize completely. We covered that yesterday. So for a strong acid that's monoprotic, which will be all of them except sulfuric acid, and I won't give you sulfuric acid, the concentration of acid and proton is the same. Well, if it's the same, it makes it easy in the sense that if you were given the concentration of nitric acid as shown here, that's a strong acid. So that means that the concentration of nitric acid is equal to the concentration of proton. So if you want to know the pH, you just do the negative log of it. Now, as I alluded to previously, you have 3.2 times 10 to the negative 3. The pH is going to be just less than 3, 2 point something. Now, in AP, you don't have to be able to get these back numbers. You just have to know it's 2 point something, and you'll get there next year. You have 2 sig figs here. You need 2 numbers after the decimal point. Plug it into your calculator. Make sure the 2.49 kicks out. You have to make sure you're calculating it correctly, because as much as I'd like to do your quiz for you, I can't.
So how do you know what comes after the decimal place if you have to do it?
You don't. You wouldn't have to guesstimate those numbers. You would have a region and be a multiple choice situation. 2.49, this too is an acidic solution because the pH is less than 7. I would like you to try the question at the top of the screen. I will do it as well, and then we can check to make sure that you are doing it correctly. Chloric acid is a strong acid, so its concentration will be equal to the concentration of proton.
Would that be our explanation?
You don't have to explain it for the strong piece. You need to know a strong acid ionizes completely, but I'll tell you it's strong for this type of question. And then watch your sig figs as well. That sometimes is very tricky. You also know that the pH is going to be 1 point something from the setup. I'll put the answer up on the screen. Yes?
Wait.
Well, I gave you 3 sig figs, so you need 3 numbers after the decimal. So the pH is a little bit different with the siggy wiggies. Yes. If you have an acid, you're going to have a strong acid equal to proton, and then you'll do it. Where it won't be negative log of proton is in the next section. So here we have pH is equal to the negative log of the proton concentration. What we're going to have in the next piece is that POH is equal to the negative log of the hydroxide ion concentration. So for acids, you'll use pH is equal to the negative log of the proton concentration. And for bases, you're going to use this piece. But you still can get the pH because the pH plus the POH is equal to 14. Question?
Do you have to write all that out then? Or can you just put it in?
I need a little work because if you write the wrong answer, I have no idea what you've done, and then you can't get any credit. So you do need to show some.
Negative log credits.
Like this.
That, yeah.
All right. So for an acid, you're going to use this. For a base, you're going to use POH. So let's take a look here in examples given. it says the hydroxide ion concentration of a solution is 1.00 times 10 to the negative 2 molar. Calculate the pH of the solution. Is it acidic or basic? And explain. So here they gave you hydroxide ion concentration, so you're going to use the pOH. Negative log of the hydroxide ion concentration, you have a 1 here, so it's the absolute value of the exponent is 2.000. How come I have 3 zeros after the decimal point? 3 sig figs here. Once I get the pOH, I subtract it from 14. Maintain these decimal places, and you get 12.000. All right? This is a basic solution because the pH is greater than 7. Here's another example written out. It says for strong group 1 bases, sodium hydroxide, lithium hydroxide, rubidium hydroxide, potassium hydroxide, etc., these two concentrations are equal because with a strong base, we know that the solution's going to ionize completely. For example, sodium hydroxide will yield sodium ion and hydroxide ion. So here, these two concentrations are equal. It's a little bit tricky if you have a group 2 hydroxide, and we're not going to get there today, so I'll hold that thought for a minute, although actually we could mention it. For example, calcium hydroxide, you have 1 calcium ion, but how many hydroxide ions? You'd have 2. So whatever the concentration is here, the hydroxide ion concentration will be twice that. So that'll be a little different. We'll get to that piece afterward. All right, so the next example here is sodium hydroxide concentration is 1.4 times 10 to the negative 3 molar. We want to calculate the pH and determine if it's acidic or basic. Again, the strong base ionizes completely, so the concentration of base here is equal to the concentration of hydroxide ion. Then we're going to do the pOH is equal to the negative log of the hydroxide ion concentration. We're going to plug in that quantity. The pOH is 2.85. 14 minus 2.85 gives us a pH of 11.15, a basic solution because the pH is greater than 7.
Can we always say like if it's equal to OH, or we have to find that out?
You need to know that the group 1 bases are strong, and calcium, barium, and strontium hydroxide are strong as well. I'll tell you for the quiz, for the test, you need to know it. All right? The quiz is going to be very simple. 50 points of the quiz is what we did the other day, and the other 50 points is going to be on this pH stuff, and we're not going to hit it all today. Do you want me to do this problem with you, or you want to try it yourself? Try it yourself. All right, go. You have 2 minutes. Rock it out. You can do it. You have 3 minutes. Today is an FS schedule day, so you'll be leaving shortly. This is a shortened period.
Would you like square it or
Square it?
no times by 2?
What?
How'd you do that?
How'd I do what? We're doing the yellow one. Yeah, no, you don't square the other one. I see what you're saying. No, you don't square it. I'll show you how to do the group 2 ones next time. This is just a little baby group 1.
Oh my god.
I copied the wrong quantity. Yes. Is what? I don't know yet. Let's be seated, please. The bell has not rung. You got the classwork, didn't you? Oh. The answer's on the screen. Let me get the classwork to you.
Oh, we got it.
Let's be seated. Let's be seated. Guys, your take-homes today. You want to be comfortable calculating pH. When given an acid, you'll do pH is equal to the negative log of the proton concentration, provided the acid is strong, which it will be. If given a base, you'll get the POH, doing POH is equal to the negative log of the hydroxide ion concentration.